let's take example 11. In example 11, we have to find the LCM of
20, 25 and 30.
Beautiful. So what is the difference? Last time we had 2 numbers. This time we got
3 numbers.
3 numbers. That is the difference. In this, there is a new method. Okay? This method is called division method. Something like that. Okay? We write the numbers as following in the row, like 20, 25 and 30. Right? Separated by a comma if you want. Okay? What we do? So all the things, what do we have in common? At least 2 should have. Both are even numbers, so minimum thing is 2, right? We start with 2. So 2 divides 10 times, 2 divides 25. No, it doesn't divide. So write the 25 as it is. 2 divides 30?
15.
15 times. So what else goes? We can factor 10. Right? We will leave this thing. We will come to this later. Okay? Okay, 2. Let's take one more time. 2. And 2 divides 10 5 times, right? Then since these two is not divisible by 2, we will write it as it is. Then we got 5, 25, 15. Then we should take the next prime factor, 3. Will 3 divide anything?
Yes.
3 divides here. So use 3. So go one after other. Don't jump to 5 right away, okay? So let's take 3. So 3 doesn't divide 5, so write 5 as it is. 3 doesn't divide 25, write 25 as it is. 3 divides 15, how many times?
5 times.
Very good. So 3 divides 15, 5 times.
times.
So then what is the other number? So 3 doesn't divide anything anymore. So next prime number we take up is
5.
5. Very good. So 5 divides everything, right? So we got 5 divides 5 one time. 5 divides 25 5 times. 5 one time. So now we got 5, 5, 5. Now, does 5 divide anything here? Yeah, 5 goes here only once. Let's do that as well. 5 doesn't divide 5, write it down. 5 divides 5 one time. 5 doesn't divide once. So just put it like this. So LCM is pretty clear. It is simple. Take all this number from this side. And LCM is 2 into 2, 3 into 5 into 5. This is the easiest way. Okay? So this most of the cases we use this. So the sum, if your product of these things is 360 or LCM is equal to 360. Some real-time, real-world examples. That is, we are taking up, we come across a number of situations in which we make use of concepts of HCF and LCM, right, in day-to-day lives. We explain these situations through few examples. Okay, example 12. Reading the question is very important. Slowly read the question many number of times. 2 tankers contain not 850 liters and 680 liters of kerosene oil. So, first draw the picture. First 2 tankers has 850 liters and 680 liters. Okay. Here you go and you get the things going like this. Okay. One tanker is going to be 850 liters. Right. So it is going to be like this. This tanker is 680 liters. Find the maximum capacity of a container. The question is to find the maximum capacity of a container which can measure the kerosene oil of both the tankers. Okay, we need only one container, something like this, which is here. You can see that here. So something like this, which can measure the kerosene oil of both the containers when used an exact number of times. The required container has to measure both the tankers in a way that the count is an exact number of times. Count is number of times we measure, okay? So its capacity must be an exact divisor of the capacities of both the tankers. That is, the capacity of this container should divide this and this, right? It should be the exact divisor of the capacities of both the tankers. Moreover, this capacity should be maximum. That is, there cannot be any other size which can be better than this, bigger than this. Okay, that means this is the biggest. Thus, if you make little bigger, then it cannot be an exact divisor. Okay, thus the maximum capacity of such a container will be. Thus, the maximum capacity of such a container will be the highest common factor, or GCD. You can call it greatest common divisor. You know what is GCD? Yes, it is other name for HCF, okay, of both 850 and 680. Highest common divisor is the maximum capacity of the container, right? So that's what we have to find. It is, how do we do the GCD? Remember, just write this 8 in the prime factorization method. We first just do it like this: 850. First, since it's even, we will take the lowest number, that is 2, which gives you 425. Then 425 doesn't divide by 3, right? So it doesn't divide by 2. So hence the third one is 5. So 5 divides 85 times. Wonderful. Then we take once again 5. This is the least number. 5 divides 17 times. Then what? Yeah, 17 divides 110. 17 is the next number. Nothing else divides, right? So all these, when you multiply, 850 equals 2 into 5 into 17, and here it goes again. We take 680 and factor it likewise. Okay, 2 times 340, then 2 times 170. Likewise, you do the factorization. Okay, 5 times 17, then 17 times 1. So all these things comes here. That is there. We take that up. Okay, we multiply all these things. Then we take the common one among them. Like for example, what are the common factors we got?
2, 5, 17.
Because 5 is here. Likewise, we rearrange. We get it like this, right? So we get 2, 5 and 17 are the highest common factors. Okay. Hence, we can see the common factors of 850 and 680 are 2, 5 and 17. Thus, the HCF of 850 and 680 is multiply these 3 together, that is 170. Therefore, maximum capacity of the required container is 170 liters. It will fill the first container in 5 and the second in 4 refills. Right? That is the trick. Okay?
Okay.